So now we have a default Max video playlist, and we have a little preview window of what the video is unaltered. And I want you guys to just take this video output and stick it into the jit.scalebias object that was put on the patch for you. Okay, and then go ahead and hit play. And you should be able to go over to your swatch over here and click on this swatch object and notice that you can change now the color of this video that's out here. So I've got a video source over at the top for my playlist. I'm sending it to my scale bias object. And my scale bias object has these attributes, these arguments, being changed by this swatch object, which you'll remember the swatch object is sending out 3 values. 0 to 1 is the range from, so red, green, and blue values. And then I'm sending them into these messages with replaceable arguments, the $1 here, so that every time I click a new color, I'm sending a new set of messages, R scale, G scale, and B scale, into my scale bias. And what this is doing is scaling, or think of it as multiplying, the values of the red channel, the green channel, and the blue channel by whatever floating point value was in this swatch color. So every single time I ask for a new color, it sends this in, the scale bias changes its arguments, and then outputs new red, green, and blue channels. So what is scale bias actually doing? Go ahead and right-click on your scale bias object, and we're going to open up the help file. And you can see that you can also use these attribute inspectors that we're really used to now, if you would like. Instead of messages here, you can certainly use an attribute inspector, and it works the same way as we're used to, where you just right-click on that inlet on the jit.scalebias, and then you can choose whichever attribute you want to adjust. And then it also shows you what the current scale or bias is for each of these channels. But the help file is actually not showing the math behind these, like what is actually happening on the planes. But there is something in Max that's going to show you how to do this. So if you go up to Help in your window and go to Reference, you scroll down to Jitter and click on Tutorials, and then Jitter Tutorial 6, Adjust Color Levels. And then up in the upper right-hand corner, there is a button called Open Tutorial. So you have 2 things here. The actual tutorial, which is paragraphs of information that you can read through. And then you also have a patch. So you click Open Tutorial, it's going to bring up this patch. You all have this on your version of Max, whatever version you're running. And this tutorial actually explains the math behind scale bias in this tiny subpatcher called Patcher Explain Scale Bias. So if you want to see what's going on here, you can look at this chili image. So click on the chilies, and then you can turn it on. And this is the same thing that we were doing before, where we're scaling the colors. So you open up this scale bias patcher. There are 2 things that scale bias can do. So the first is scaling or multiplying, which we just looked at over here. We're creating these floating point values, these scaling factors, or multiplying the channels. Biasing is addition. Bias is adding, scaling is multiplying or dividing. And in this patch, you can experiment with what these arguments, these scaling values are that you actually apply So you can, in this vein that we are in this week of getting down to the smallest, minute detail of math on pixels, we literally have a 1 by 1 plane matrix, that is 1 pixel, with 4 planes, so it has a red, a green, and a blue value, and we can actually look at its color. So if we want to start out with, say, a value of 100, right? This value is setting the green plane to 100. We could move this up if we wanted. We can see that as we increase the value of our green plane, our green color is getting brighter. 255 is as high as we can go. This is the brightest, greenest channel that you can get, or you can go all the way down to 0, and then you would have black.
But why is it green in the first place?
The example chose green. It's setting, so this argument here, set cell 0, 0, plane to value 1. So plane 2, in this case, is the green plane. If we change this, we could use modify a different plane. It's just green is our example here. Okay, so our original is, let's say, 100. This is the color that it looks like. And right now, our scale argument for scale bias is 1. So when we multiply 1 by 100, we get, here's our green output, we get 100 right here. So this is the resultant char value. So if we change this to, I don't know, 2, let's try 2. Right now we're going to scale this value by 2 instead of 1, and voila, we have multiplied literally this green value in this value in this green plane by 2, and the output right here is 100 times 2, 200. So let's put this back to 1. We will hit our bang to send our 100 back. If we are adding, biasing instead of scaling, this is a different operation. This is adding. So let's put something in here to experiment, maybe 0.5, and send this through. Okay, so something funky has happened. We added 0.5 to our original value of 100, and we got 228. Let's add 0.75. Now we've maxed out here. So let's experiment with something a little lower. You start with 50 and add 0.5. Now we're at 178. What if we do 1? Okay. So, any thoughts about what might be occurring here? Because we just added 1 to 50. I would have expected that we got 51. That didn't happen. So what did happen? In scaling, like if we're thinking about this as multiplying by 2, we can think of it as 50 times 2. Right? But what we're actually using here are floating point values. And so if you are biasing and you're adding here, the bias argument is not thinking in character data. It's not thinking in integers. It's not thinking in 8-bit. It's thinking in 32-bit, which is confusing. So let's put this back to 1. And instead of thinking in 8-bit in character data right now, let's switch our mind into 32-bit and think about this as a floating point value from 0 to 1 instead of a char type data from 0 to 255. So I'm going to, let's put this back to 100, okay? And when you divide by 255, you get the equivalent decimal value. So now we're going to start thinking about this with floating points. If I have a value of 100, that's a little over a third of the way to 255. You can think of this as 0.392. So we're a little over a third of the way to 1. And as we add in these values, these biasing values, we are adding in to this decimal point. So I've got 0.392 plus 0.21. My result is 0.6.